everyone. My name is Tim. I'm a product manager at PegaSys. And today I'm going to talk about the transition from Eth1 to Eth2. Let me just share my slides here. Okay, so a couple of you may have seen these tweets recently where Vitalik put up what he thought would be the roadmap for Ethereum for the next 5 to 10 years. And today I'm going to focus on a subset of that, basically where Ethereum is today and what's needed to get from an Eth1 to Eth2 transition, which is this box on the diagram. And before we talk about that, it's worth stepping back and asking why we actually need a merge from Eth1 to Eth2. And as many people today have alluded to, the Eth2 beacon chain will actually be launching completely separately from Eth1. So this means that while the validators for the proof of stake engine will all be on Eth2, Eth1 will still be the chain that stores all of the Ethereum state. And the Ethereum state contains all of the contracts, so all of the application, as well as all of the balances on Eth1. And that means that if we want these applications to keep working and to transition to Eth2 smoothly, the best way to do that is to basically merge all of Eth1 into Eth2. And this is what we'll be talking about. So at a high level, there's 3 things we need to get to this Eth1 to Eth2 merge box. The first part is we need to make Eth1 stateless. What this means is that we need to separate the state storage from its execution. And the reason for this is that this is how Eth2 has been designed from the get-go. Whereas Eth1 typically stores all of the state on each node, Eth2 doesn't require that. And we want to move Eth1 towards that model before we merge it into Eth2. Then we need both phase 0 and phase 1 of Eth2 to be live. So like was mentioned many times today, phase 0 is the beacon chain of Eth2, which is what brings us proof of stake. And phase 1 is what brings us the sharding system for Eth2. And before we transition the current Eth1 system over, given that there's huge value associated with it, we want to make sure that both those phases are live and battle tested. And then finally, the third thing we need is this Eth1, Eth2 client merge spec. So because we have Eth1 clients today, clients like Parity, like Geth, like Beiko, and Nethermine, and we have Eth2 clients that are being developed like Prism, Teku, Lighthouse, we need to find a way to make sure that the functionality across both those clients gets merged in a clean way to have a coherent whole once Eth1 is operating inside of Eth2. And so let's first look at the bit around making Eth1 stateless. This is kind of this upper part on Vitalik's diagram. And to take a step back and explain kind of why we want to do statelessness and what it is, it's worth going back a couple years to DEF CON 4 in 2018, where there was a core developer meeting discussing the rapid growth of the Ethereum state size. So there were more and more contracts being deployed on Ethereum, storing more and more thing, and it created a really high storage demand on nodes on the network, and people wanted to address that and make sure that we wouldn't get to a spot where people could not run nodes because there's too much state on them. And the first idea that was proposed to address this was the idea of state rent, which was kind of pursued over the next year. And the idea there was that instead of paying gas one time to add smart contracts and data to the Ethereum chain, you would pay a rent fee. So it would be an ongoing fee. And if you stop paying it, then your data would be removed from the active state. And obviously, this kind of is a whole new paradigm than what we currently have on Ethereum. So it would have broken pretty much every contract on chain. And it was really hard to evaluate the long tail impact of this breaking change. So because of those difficulties, this work was paused. And so at DEF CON 5, so last year in 2019, there was a call made to still revive those efforts around kind of curbing state growth, but using a different approach, which is stateless execution. And what stateless execution does is it adds a witness to every transaction on Ethereum. And this witness represents the parts of the state that are touched on the Ethereum state. So this means that when a node receives a transaction alongside with a witness, it's able to actually execute this transaction against the witness because it has all of the bits of state that it needs to execute. And the consequence of that is that nodes don't need to store a full copy of the state but only the parts that they're interested in. So you get to a spot where it's not every node on the network storing a full copy of the state. And if we want this to happen on mainnet, there's 4 main things that we need. The first is witness compression. So these witnesses that we mentioned are about 10 to 100 times larger than current Ethereum blocks. And this means that if we want to propagate them on the network at the same rate that we propagate blocks today, we have to compress them by about that order of magnitude. Similarly, we need something called a state provider network. So if the nodes are not each storing the state and being responsible for it, it needs to be stored somewhere, and there needs to be a way for nodes to request it. And obviously there's a cost associated with that, so we need to figure out the incentives. The third thing we need is gas repricings. Because when we generate these witnesses and we verify them, it requires computation, just like executing transactions on the EVM. We need to figure out what's the best way to charge for this and to reflect it as part of the gas schedule. And finally, the last thing we need is static state access. So right now, the way the EVM works is it can dynamically decide which part of the state it'll access as it's executing a transaction. This makes it really hard for witnesses to be generated because you don't know in advance all of the pieces of the state that you'll touch. So if we had static state access, it would make this much easier because we know when we're starting to execute a transaction, which are the bits of the state that we'll be touching. But this is not a must-have. You could call it a very nice to have for stateless Ethereum. And like I mentioned at the very beginning, Eth2 was designed from the start to be stateless. So that means if we make Eth1 stateless, not only are we solving the state growth problem, but we're also helping merge Eth1 into Eth2. So now if we move to the Eth2 side on phase 0, there's a couple of things we need here as well. The past few talks have hinted to this, but it's worth noting that once we have phase 0 going live, we'll be in a spot where we can actually kind of move things forward, and we have a few steps to get there. The first is client optimizations. So we've started to see some testnets, some single client testnets a couple of weeks ago, a multi-client testnet being set up this week. And as clients kind of run on these testnets, they find which optimizations they need and improve things like their sync times, their querying throughput, the amount of memory they consume. So this is a big chunk of work. Again, multi-client testnets. So like I said, before we launch phase 0, we want to make sure that we have kind of a long-lived multi-client testnet to be sure that the clients can actually work together smoothly over a long period of time. And as we're going through this process, we'll probably want to have more audits. So right now, we've audited the deposit contract and the phase 0 spec. But I think in the coming months, you'll probably see some more client code-based audits, as well as potentially a formal specification of the phase 0 spec. And finally, the last thing we need before going live to phase 0 is the deposit contract. So in order for validators to register at the stake on Eth2, they have to deposit their ETH on an Eth1 deposit contract, which has to be deployed on chain. And here it's worth touching also on this emergency merge box that's on Vitalik's diagram. So there's been a lot of conversation around why can't we just move Eth1 to Eth2 as soon as the beacon chain is live and have proof of stake instead of proof of work. And this would actually theoretically be possible, but it comes at a high cost, which is why Vitalik referred to it as an emergency merge. And the cost that you get here is that if we do this merge right now, all of the Eth1 nodes will still need to store all of the Eth1 state, right? We haven't gotten kind of the stateless Ethereum work done. And this means that we'd be nullifying this property that we kind of worked hard to get on Eth2, which is that nodes don't actually need the state to hold all of the state, sorry. So if we wait slightly longer and we actually implement all of these changes from stateless Ethereum before merging Eth1 to Eth2, we're not bringing all of this state debt to Eth2. But again, it would still be possible to do this merge if we absolutely needed to. So that's it for phase 0. Now let's look at phase 1. And for phase 1 to launch, there's basically 4 things we need, which are pretty similar to phase 0. The first is we need to finalize the spec. So right now, most of the community and most of the eyes are focused on phase 0, but as that gets deployed, there'll be more and more people reviewing the phase 1 spec. We'll have some more audits on it. And once it's kind of done, we'll freeze it like we froze the phase 0 spec last year. Then we'll need to implement phase 1 clients, just like we implemented the phase 0 clients. And instead of running the beacon chains, the phase 1 clients will be running the shards. Similarly to the actual phase one spec, there's also a peer-to-peer networking spec that we'll need to review as phase one goes live. So this was defined kind of pre-phase 0. And as we obviously go live, we're going to find a lot of edge cases and nitpicks that we'll need to adjust in it. And just like phase 0, we'll want to audit all of this. So both the spec, the clients will need to undergo audits to make sure that we don't have any issues. And again, as it was noted in previous talks today, phase 1 will allow Ethereum to store about 1,000 times more data than it currently does. So these 64 shards that will be deployed will allow applications like optimistic rollups to commit data to those shards and to access it on the network directly. So we've done phase 0, we've done phase 1. The other bit that's missing is the Eth1 to Eth2 merge spec. And this is probably the bit that's been worked on kind of the most recently. And so there's not that much to go off here. The best resource on this is Danny Ryan's ETH research post, and it kind of defines what an Eth1 client and an Eth2 client could look like in a post-merge world. If we start on the Eth1 client side, the Eth1 client would basically delegate all of its consensus to the Eth2 client. So this means that the Eth1 shard gets built by the proof of stake engine on Eth2. And the Eth1 client then isn't really a full client anymore, but what Danny Ryan calls an Eth1 engine, which is in charge of processing the state, the transactions, the EVM execution, and whatnot. And it's basically a microservice that will report back the information to the Eth2 client using an RPC endpoint. And again, because this is not a full client, it's not managing its own shard and building its own blocks, you couldn't really run it without an Eth2 client. And there was a diagram to the post that showed us what this would look like. If we look on the Eth2 side, as we said, this would be handling both the proof of stake and the sharding consensus. So it's really the whole consensus engine. And that means it's managing both the Eth1 shard as well as the other 64 data shards. Again, it would communicate with the Eth1 engine over RPC to get information, and then it would be in charge of gossiping the Eth1 shard blocks. And this means that you could run it without an Eth1 engine where the Eth2 client would store the information about the head of the Eth1 shard, but it wouldn't be able to validate all of the transactions itself. Again, this is what it looks like from a diagram perspective. So to kind of recap all of this, if we want to get from Eth1 to Eth2 and merge Eth1 into Eth2, there's 4 main bits of work that we need. The first is stateless Ethereum. So we need to make the network stateless, which will not only make the 1x network today more sustainable, but it'll align it with the way the Eth2 spec was designed. Then we need phase 0 to be live and running, which is our proof of stake engine. We also need phase 1, which is our sharding consensus engine, which allows the management of all of the shards, including the Eth1 shard. And finally, we need this Eth1 to Eth2 client spec to make sure that we have a clear relationship defined between both clients and we don't lose any functionality. So to summarize all of this, the Eth1 to Eth2 merge is happening, and we're at the point where we're figuring out the implementation details, which always looks messier, but this is because we've moved from this high-level roadmap to actually getting it done and are working through the nitty-gritty of what this will require. Again, it's worth noting that merging Eth1 into Eth2 will provide the smoothest transition for users and developers. So for anyone within the Eth1 chain, you shouldn't really notice anything happening. This is really going to happen more at the client and the protocol level. And the goal is to have a very smooth transition. And finally, once the merge is done, we're really going to start seeing more experimentation with different type of executions going live within Eth2. But right now, the community has really shifted its focus to making sure we get the Eth1 shard merged into Eth2. Oh, and that's all I had. Thank you for listening. If you want these slides, you can get them here at this bit.ly link or scanning this QR code. Thank you very much.